Hi, my name is Jett Gleason. My student ID is Z5575668, and this is my student ID. I am answering questions to Experiment 1. Firstly, Kepler's 3 laws. The first law is related to orbit and claims that planets will move in a circular ellipse around a focal point like the Sun. The second law is related to the area of a planet from the Sun and claims that a line sweeping from the Sun to the planet spans equal areas at all points of the orbit. The third law states that the squared orbital period of the planet is proportional to the semi-major axis of the orbit. So, the closer the planet is to the Sun, the faster the orbit. In my response to question 9, I said that the planet does not appear to move as the moon orbits, but it would actually because the masses aren't extremely different. For question B, the center of mass in question 1 is in the Sun because the mass is so large. The center of mass in question 4 is somewhere between the Earth and the Sun, but closer to the Sun because of the large mass. The center of the mass in question 7 is also somewhere between the Earth and the Sun, but closer to the Sun because of the large mass of the Sun. C. This scenario is different in a planet-Sun ratio scenario. The center of mass in the Earth-Moon orbit is between two celestial bodies, closer to Earth, so the planet would move as the Moon orbits. The center of mass in the Earth-Sun orbit is in the Sun, so it would not move. Question 11. There are 2 astronomical units between the planet and the Sun in the original experimental diagram. For question 14, I set up 4 different new orbits, and I found that the response is yes. The further the planet is from the star, the lower the velocity required for a circular orbit. My first image, I picked an astronomical distance of 1.5 astronomical units, and the orbital period was 211 days. I then picked 0.5 astronomical unit distance, and the orbital period was 50 days. I then picked a 3 astronomical unit distance, and the orbit was 607 days. Finally, I picked a 4 astronomical unit, and the orbit period was 1,251 days. So the larger the astronomical unit, the larger the orbital period. For question 15, A, I expect Mercury, which is the closest to the Sun, to have the fastest orbital velocity. B, I expect Neptune, which is the furthest from the Sun, to have the slowest orbital velocity. And C, the planet closest to the Sun has the fastest velocity because it experiences the most gravitational pull, making a shorter orbital period. The planet furthest from the Sun has the slowest orbital velocity because it experiences the least gravitational pull, creating a longer orbital period. This concept relates to Kepler's 3rd law because it shows that objects near a larger mass will move faster due to more gravitational force. Overall, this experiment made me understand the relationship between celestial bodies and velocity, and how the gravitational pull of an object will increase or decrease the velocity of an elliptical object around it. This experiment also allowed me to visualize how the Earth moves around the Sun and why we have an elliptical orbit. I did not use any external references or research other than what was presented in class. Thank you.